Couple things to recognize in these problems here, 88 through 98 even, which are the ones that I'll be doing. Two things. Number one, every single one of these problems there's a y, and every single one of these problems there's a c. The y is what we're solving for, and the c just represents any constant. It could be, it's not a variable, it's any constant, and you treat it just like you would any number like 3, 4, 5, 6, 7, any 2.5, any constant. So you're just, I really like these problems because they emphasize the need to solve for y, the need to also use the properties of logs that you've been learning. So let's go ahead and get started. For number 88, we can see that we have on both sides of the equal sign, we have log of something, and over here log of something. Well, if we have the log of something equals the log of something else, and those two logs have the same base, which they do, they're both base e. In fact, every problem in this section has up through 96 has log base e. So if the logs are the same base, which they are, then we say therefore, just like when we solved exponential equations, therefore, in this case, if the logs have the same base, the arguments have to have the same value. So if we can get log same base on both sides, then we can just equate the arguments and we're done. That's it. Now, we don't have one log on one side on number 90 and all the rest of them. We don't have just one log on one side and just one log on the other side. So that's our goal, is to get just one log. Get just one log. So we already have one log on this side, so we'll rewrite that. But on this side, we're going to have to combine the logs. You can't combine logs with the numbers out front like this, so you can't just combine these. We have to use the properties of logs before we combine them to move any coefficients to the exponent position. So if you remember, 2 times ln of x is the same thing as ln of x squared. Now this log has it doesn't have a coefficient other than 1 or -1. And this log also, nothing in front. So that's the case. If that's the case, which it is, now we can go ahead and combine these logs. So we have the difference of logs, which means we have the log of the quotient. So if we have the difference of logs, we have the log of a quotient, and then we still have that plus ln of c, and keep in mind we have the ln of y over here, and then now we have the sum of logs. And when we have the sum of logs, we have the log of the product. Cx squared over x plus 1, so it's c times this fraction, or this fraction times c. We can write it like that. Now we have the situation that we've been waiting for, where we have one log on one side, the same base as one log on the other side. So therefore, we equate the arguments. So we have y equals c times x squared all over x plus 1. Now, number 92. We have, now here's the situation. We have one y over here we're solving for, and we have some other stuff. All that stuff is just, we're still trying to get y by itself. So there's no other y's over here, so now we just convert this to exponential form. E to the -2x plus ln of c is equal to y. And we could leave it just like that. I could simplify it a little bit more, but I would allow that. I would just allow that. Answer in the back of the book is something different than that, and I'll show you what the answer in the back of the book is, if you'd like. We've got e to the -2x times e to the ln of c. So the reason why we're able to do that is what I had said earlier. I'm looking for that problem. Go back to this. So if you look at this right here, if you take a to a power and multiply it by the same base to another power, then you add the powers. Okay, so one base, add the powers. Well, we're reversing that. We have one base, add the powers. We split it up into one base to the power times that same base to the other power. And then the reason why we do this is because this guy has a value of just c. E to the ln of c is just c. So we can rewrite this as e to the -2x times c, or it kind of looks better when you put the c out in front and you write it as c times e to the -2x. So just in case you wanted to take this problem a step further and further simplify it, that would be the absolute best simplified version. All right, so looks like number 94, we've got the same situation as number 92, but actually I will start a new video for that one.